All right, section 4.4, undetermined coefficients. So section 4.3 was all about solving the homogeneous linear equation. Now, section 4.4 is about solving the non-homogeneous linear equations, right? So these are the ones where the right-hand side is non-zero, right? When the right-hand side is non-zero. So we've got an, we also got constant coefficients, I should say, right? Oops. So we're in a similar setup to what we were in 4.3. Some coefficient, nth derivative, some coefficient, n minus 1 derivative, all the way down. Some coefficient, y equals g of x, which again, non-zero, right? And this only works when g of x, there's undetermined coefficients, I should say. Undetermined coefficients only works when g of x is a constant, a polynomial in x, something involving e, so like e to the alpha x, sines and cosines, or, this should be or, not of, lots of typos in these sections recently, or finite sums and products of these things. So we're thinking gx's that look good are like g of x equals 30, g of x equals x cubed minus 3x squared, g of x equals e to the something plus a constant, right? Remember, finite sums and products are okay. G of x equals sine x minus a polynomial times e to the x, right? This is a product. X times e to the x plus constant times cosine 5x, you know, like things that look like this, right? These are good. Good. We like these. Undetermined coefficients will work. Things that are bad. 1 over x, not good. Natural log x, no good. Any other trig functions other than sines and cosines, no good, okay? We need good looking g of x's to do this undetermined coefficients method. So here's an example. We want to find the general solution for this differential equation, right? Linear, constant coefficients. The right-hand side are g of x, right? It looks good. It's a polynomial in x. I can handle that. Step 1, find the general solution, sometimes call it the C, right? For complementary solution. Find the solution for the associated homogeneous equation. So we're gonna set the right-hand side, we're gonna erase it and put a 0. And then we're gonna solve that equation with 0, right? That's step 1. So the auxiliary equation for that is m squared, right? Two derivatives, 2 powers of m. 1 derivative, 1 power of m. No derivatives, no powers of m. M squared plus 4m minus 2 equals 0. We do our little quadratic formula. We get negative 2 plus or minus root 6. This is a pair of real solutions, right? This is a pair of real solutions. So we get c1 e to the negative 2 plus root 6x plus c2 e to the negative 2 minus root 6x. This is our complementary solution, right? So this is step 1. This is step 1 every time. Find the solution to the associated homogeneous equation, right? Solution to the associated homogeneous equation. Here it is. This is step 1. Step 2 is you're going to find a particular solution by guessing something that looks like the g of x on the right-hand side, right? We want to pick a solution y that looks like g of x. That's kind of the idea here. So I'm going to guess that yp is something like ax squared plus bx plus c, right? Now just plug it in and match the coefficients across the equal sign, right? So if you plug in this yp into this differential equation, right, you'll be able to take derivatives of this y, plug it in over here. You'll get some expression with a's and b's and c's, right, over here. And you're going to set that equal to the actual value. And then we're going to match we're going to find the x squareds on both sides. We're going to find the x's on both sides. We're going to find the constants on both sides. And we're going to match the numbers to the a's, b's, and c's. Right? Match a number to some a, b, and c's. Let's see how it goes. So yp is ax squared plus bx plus c, right? Which means the first derivative is 2ax plus b, c goes away. And the second derivative is just 2a. So these are my y, y prime, and y double prime. I plug that into the differential equation, right? I plug in y double prime, I plug in y prime, and I plug in y. 2a, and I plug it into this differential equation, I should say again, right? So you're going to get 2a plus 4 times whatever y prime is, minus 2 times whatever y is. 2a plus 4 times this, minus 2 times this, equals, this is g of x, right? This is g of x. Okay. Now, I'm going to collect up all the x squared terms on the right side, right? Where are my x squared terms? I got one here. That's it. Negative 2ax squared. Negative 2ax squared. I'm going to collect up all of my x terms, right? All my things multiplied by x. Where are they? There's an x here, there's an x here. So I get a 4 times 2ax, and then I get a negative 2bx. Boom. Then I collect up all my constants. This has no x's. 4b has no x's. Negative 2c has no x's. That's this right here. Right? I'm going to collect up all my x squared terms, all my x terms, and all my constant terms together. And then I'm going to look across the equal sign. Look across the equal sign. Here's all the x squared terms. Here's the x squared term. Here's all the x terms. Here's the x term. Here's the constant term. Here's the constant term. And I'm just going to say, negative 2a better be 2. 8a minus 2b better be negative 3. 2a plus 4b minus 2c better be 6. Right? Boom. This right here, system of equations. We can solve it. Solve for a first. You get a equals 1. Plug that in right here. Solve for b next. You get b equals negative 5 halves. Plug that in here. Plug the a in here. Solve this again. You get c equals negative 9. Suddenly, I've solved for a, b, and c. I've matched coefficients, right? I used a, b, and c, right? A, b, and c are my undetermined coefficients. Undetermined coefficients. And now, they are determined. I found my particular solution, right? I found my particular solution. And by the superposition principle, of section 4.1, I know that my general solution to this differential equation is the homogeneous solution plus the particular bit, right? So I take the homogeneous solution and then I tack on yp. Tack on yp. This is my general solution to the non-homogeneous equation. This is the method of undetermined coefficients, right? This is the method of undetermined coefficients. I pick a yp, so, okay, step 1, solve the homogeneous equation. Solve the associated homogeneous to get yc. Step 2, find a particular one that looks like g, and hopefully it works out. There are some caveats. We'll run into those in a second. Excuse me. Okay. Number 2. Y double prime minus y prime plus y equals 2 sine 3x. Okay, step 1. Find the complementary solution, or the solution to the associated homogeneous equation, right? So we pass to this, and we just set the right-hand side equal to 0. So we pass to the auxiliary equation and set the right-hand side equal to 0. Factor this, we get complex conjugate roots. Alpha is 1/2, beta is root 3 on 2. My complementary solution is e to the 1/2x, c1 sine of beta x, C2 cosine of beta x. And now, if I look over here, right, this is my g of x, and I'm going to guess something that looks like g of x for my particular solution. But because I'm taking derivatives, okay, sines and cosines, they like to flip back and forth, right? If I'm taking derivatives of sines and cosines, right, they're going to flip back and forth. Oops. Just like this, right? They're flip-flopping. So my particular solution is going to be some number times the sine of 3x, again, sine of 3x, plus some number times the cosine of 3x, again, this 3x, right? Now, if I take derivatives, I get the first derivative is 3a cosine 3x minus 3b sine 3x. And the second derivative is negative 9a sine 3x minus 9b cosine 3x, right? Now I'm going to just plug these in. I'm going to plug in yp, yp prime, and yp double prime into my differential equation. And I'm going to match coefficients across the equal sign. Right? Yp double prime minus yp prime plus yp is equal to, I'm collecting up sines and cosines here, by the way. I should say that, right? So for the cosine term, I've got yp double prime cosine term, which is negative 9b, minus yp prime's cosine term, which is minus 3a, am I crazy here? I'm looking at the cosine term. Negative 9b plus b. I think I've got my sines and cosines flipped here. I've got a negative 9b minus 3a plus b. That should be negative 8b minus 3a. I see. Negative 8b minus 3a. Whoops. And then for the sine term, I got a negative 9a. I've got a minus plus 3b. And then I've got a plus a. So that should be negative 8a plus 3b. Okay, so I swapped my a's and b's, it looks like. It happens. And then I'm going to match that to, where is it? To my g of x, right? 2 sine 3x. Gonna match it, right? So I've got 3a minus 8b equals 2. Oh, I did it right down here. I just messed up the middle step somehow. 3a minus 8b equals 2. And then I've got negative 8b minus 3a, I don't know what is going on, equals 0, right? Which tells me that a equals, rough, b equals negative 3 over 8, a, which means, plugging that in here, that's going to clean this up pretty nice. B equals, is that right? Yeah, 6 1/2, right? I get, plugging in for B here, I get positive 3, so I get 6a equals 2, which means a equals 2 over 6, which is 1/3. And that means if I plug in 1/3 here, I get negative 1/8. Right? So B was on the cosine term. So I get a positive 1/3 here and a negative 1/8 here. And then I get a negative 1/8 here and a positive 1/3 here. Okay. That was a little rough. But we did it. And again, the deal is, to get the general solution, right, you take your homogeneous solution and then you tack on the particular solution you just found. So, okay, the real deal here was that we needed to pick yp that looked like g of x. But since it has a sign on the right-hand side here, since my g of x includes a sine 3x, I got to pick a yp that includes sines and cosines because they flip back and forth when you take derivatives. Okay. Next example. Hopefully this gets better. Whew, it's rough right now. Okay. Number 3. Y double prime minus 2y prime minus 3y equals 4x minus 5 plus 6x e to the 2x. Okay. Normally, okay, let's go one step at a time. Step 1. We're going to solve the associated homogeneous equation, right? M squared minus 2m minus 3 equals 0. Factor that guy. I get my, excuse me, my homogeneous solution is c1 e to the 3x plus c2 e to the negative x. Okay, good. Notice how there are no e to the 2x's hanging out over here, okay? E to the 3x and e to the negative x, that's good. Now my guess for my particular solution, this is kind of like a combo g of x, right? This is like g1, this is like g2, right? I need to kind of use superposition to pick these separately to find my big yp, right? So my first yp guess is going to be a linear equation bit, just like this bit, right? This matches this. And my next bit is going to be a polynomial times e to the 2x. So really when I see this, I'm guessing my yp looks something like ax plus b times e to the 2x, right? I pick a linear polynomial out front, and I go all the way down as far as I can with the coefficients. But in this case, since a and b are used up here, I'm really going to pick, cx plus d times e to the 2x. Right, that's what I'm picking for my yp2. And you can see on the next page, if I FOIL this out, right, I get cx e to the 2x plus d e to the 2x. That's this right here. Right? If there's a polynomial involved, you always count down from the highest to lowest. So like since there's a 6x here, I'm going to pick cx plus d times e to the 2x, right? And I count all the way down. Okay. Here's an example. If g of x looked like x squared e to the alpha x, I would pick yp that looks like this, right? ax squared plus bx plus c e to the alpha x, right? I would count all the way down as far as I could. One moment. So after I find yp, I just got to find the derivatives of it and plug it in, match coefficients, right? Yp prime equals, this is just derivatives, right? Take a derivative of this, I get a. Take a derivative of this, I get a product rule, right? On this term. This becomes 2cx e to the 2x plus c e to the 2x plus, and this term is just the easy derivative, 2d e to the 2x. And then I take another derivative, right? This goes to 0. I get another product rule here. the c e to the 2x is this derivative, and this is that derivative, and I can clean it up just a little bit, right? Now back to the differential equation. I plug in yp double prime, yp prime, and yp into my differential equation, right? Yp double prime minus 2yp prime minus 3yp, right? This is messy, this is messy. We're collecting up coefficients, stuff in front of an x, constants, stuff x e to the 2x, stuff e to the 2x. Still combining a little bit, right? Still combining this down, still combining this down a little bit. I get stuff in front of the x, the constant. I get stuff in front of x e to the 2x, and then I get stuff in front of e to the 2x. And that's equal to, across the equal sign, right, the g of x, right? That's equal to this. So now I'm matching coefficients, right? I'm matching coefficients. I got negative 3a equals 4. I've got minus 2a minus 3b equals negative 5. I've got negative 3c equals 6. And then I've got 2c minus 3d equals 0. 2c minus 3d equals 0, right? So I get a equals negative 4 over 3. And then I can plug that in right here to get b equals 23 on 9. This gives me c equals negative 2, and I can plug that in right here to get d equals negative 4 on 3. And then this is my particular solution. This is my homogeneous solution, and when I add them up, right? When I add them up, I get my general solution. There are some possible issues if g has the same form as one of the solutions in yc, right? And it's going to be similar to when we had repeated roots, right? So let's just look at this example. Y double prime minus 5y prime plus 4y equals 8e to the x. If I factor my auxiliary equation to find my homogeneous solution, I get that roots are 4 and 1. So my homogeneous solution, right? Homogeneous solution is constant e to the 4x, constant e to the x. Now, issue arises. This looks like g, right? They both have an e to the x times a constant. That's bad news bears for the particular solution. But we can get around it just in the same way we did when we had repeated real roots. We're just going to tack an x on to our particular solution, right? Here's what happens if you guess yp equals 8e to the x. You do it all down and you get 0 equals 8e to the x. Why? Because this is a solution to the homogeneous. Which means if I were to plug this in for y, I'm going to get 0 on the left-hand side every time because this solves the homogeneous equation, right? This is a solution to the homogeneous equation. Okay, well, how do we get around it? We tack on an x. We tack on an x. Now when we take our derivatives, right, we're going to get product rule here, and then again we get product rule here. And when we evaluate it, things work out, right? Collecting up terms, we get an 8e to the x plus 0xe to the x equals 8e to the x, which means a equals 8. Simple. Which means our general solution is c1 e to the 4x, c2 e to the x plus 8x e to the x. Here's a nice little table for you. So assuming that no functions that look like g of x are in your homogeneous solutions, here's a table of some good guesses, right? When the right-hand side is a constant, you pick a constant. When the right-hand side is a polynomial, that should be a squared. When the right-hand side is a second-degree polynomial, you pick a second-degree polynomial. When you have sine or cosine, you always pick sine and cosines together. When you have an exponential to a power, you pick constant times exponential to that same power. When you have a linear equation times e, you pick a linear equation times e. When you have a quadratic times e, you pick a quadratic times e. When you have e times sine, you pick e times sine, e times cosine. When you have a quadratic times sine, you pick quadratic times sine, quadratic times cosine. What should we have? Right? Quadratic times sine, you get quadratic times sine, quadratic times cosine. When you have linear times e times sine, you pick linear times e times sine, linear times e times cosine. That's how it goes, right? This is like a little cheat sheet for you to pick your particular solution based on G. Again, assuming that nothing that looks like G solves the homogeneous equation. Because if it does, you need to compensate, right? And add in this extra x. You just go up a power. So here's some easy ones, right? We're going to determine the form of a particular solution, but we're not actually going to solve it, right? We're going to determine the form, but we're not actually going to solve it, right? So we've got this equation with this right-hand side. Okay, this is our g of x. A little gnarly. We've got a cubic times e. We've got, this can be rewritten a little bit, right? This is like 5x cubed minus 7 all times e to the negative x, right? Let's hope there's not a cubic times e that shows up. Okay, solving our associated homogeneous equation gives us complex conjugate roots. Already I can tell we're going to be smooth sailing. We get e to the 4x times sines and cosines, right? This is alpha, this is beta. Again, this is alpha. These right here are beta, right? Particular solution, guess, g of x equals 5x cubed minus 7 all times e to the negative x. And nothing in here looks like a cubic times e to the negative x, right? Nothing up here looks like a cubic times e to the negative x. So we're just going to pick a cubic times e to the negative x as our particular solution, right? That's our yp. That's going to be our guess. Linear equation times e to the negative x. Let's go again. Y double prime minus 9y prime plus 14y equals 3x squared minus 5 sine 2x plus 8x e to the 6x. Okay, we're going to solve our associated homogeneous equation, which gives us this. And again, I'm looking, right? G of x has a quadratic polynomial, has a sine, and has an x e to the 6x. There's no e to the 6x's in here, only 7 and 2. So I think I'm good to just pick something that looks like this, right? I'm going to pick a quadratic polynomial. Why did I pick a cubic? Oh no, this should be a quadratic guess. Should be a quadratic guess. Anyway, let's fix that. Boy, real embarrassing today. A lot of little slip-ups in the notes. Square C. Okay. Fair enough. Since g of x doesn't have anything that looks like that, we're just going to pick a quadratic polynomial. Then we're going to pick sines and cosines with 2x, right? And then we're going to pick a linear polynomial times e to the 6x. That's it. C. Y double prime minus 2y prime plus y equals e to the x. I've got passed to my associated homogeneous polynomial, or auxiliary equation. I factor it. I get e to the x, and e to x e to the x is my, this says positive 1 as a double root. Right? Positive 1 is a double root. That means my homogeneous solution is c1 e to the x, c2 x e to the x. Now, I'm looking at g. G is e to the x. I've already got that showing up, so this ain't gonna work, right? If I tack on an x e to the x, that's already showing up too. So that ain't gonna work. That must mean I have to pick ax squared e to the x, right? And you can, I mean, you can do it like this if you want to. It won't help anything. Ax squared plus bx plus c. E to the x, right? That's a good guess too. Okay, that's how you do method of undetermined coefficients. I hope that was helpful.